Welcome everybody. Welcome to the LSA and our Thursday talks series. Being online, it's always hard to really see you all out there, but I'm guessing you are, and I'm pretty sure you are. So really good to see you all again. My name is Samantha Hardingham. I am the academic director at the LSA and have the pleasure of hosting these talks on a Thursday lunchtime. And today, very, very pleased to welcome both Viral and Sergio from IDOM. IDOM have been amazing supporters of the LSA since its founding. So a long-standing relationship with the practice as one of the founding practices in the network. Viral, new managing director, relatively new managing director, I would say. So really welcome to you, and to Sergio, who Viral is in the London office. Sergio, sustainability lead, who is joining us from Madrid, and that, I guess, is a very good indication of how the practice operates. It operates globally across many countries, particularly across the UK and Spain. And the focus of the practice being an architectural and engineering firm, really very, very focused on a holistic approach to design, sustainability at the heart of everything you do, particularly in the light that you have a building physics team, of which you are the lead, Sergio. You are going to, I gather, talk mostly about focus on one building, which is your HQ in Madrid, but perhaps one or two other projects, which I won't spoil the surprises. So without further ado, really, I hand over to you both, and we will pick up with some questions shortly, once you have completed your talk. So over to you guys.
Okay. So welcome everybody. Yes, yes, my name is Sergio Arús. I am the sustainability lead engineer for the IDOM team for the architecture department. And today's talk will be focused on how to reduce building energy use through advanced engineering systems. And particularly, I'm going to be focused on the solution that we believe a lot, which is the TAPS, which is the acronym for thermal activated building structure. So, let's see. Yes. So yes, where I'm sitting now is the Madrid headquarters for IDOM, and this building was done in 2010. I will go first to talk a little bit about how important is the building sector, no, in Europe. I mean, if we think about energy and carbon dioxide emissions, I mean, we know that the emissions of the building sector are around 40%, a little bit less of the whole emissions and of the whole energy consumption in Europe. No, so it's quite a lot. It's quite representative and very important. And if we think about the relation in population regarding cities and the rest, we see that there's a tendency that in the whole world, more and more people are living in cities. So we have different issues. One is the global warming, but also we have issues related with the cities, like the local heat island effect that can occur in cities. No, so when we speak about energy efficiency, we need to think also about this tendency that more and more people are going to live in cities, and with these particularities that we have in cities. And we speak about energy performance and how is this related with the regulations in Europe. We see that it's a kind of a revolution in the last years. Everybody knows that it's quite a lot of focus in trying to reduce the consumptions in buildings, because we are quite worried about global warming and all of these consequences that will be with the global warming. So, I mean, the new directive that it was from, I mean, it took place in 2020. I mean, this nearly zero energy building, we have made a huge change. It's like a new paradigm regarding energy performance for buildings. We need really to focus in cost-efficient measures and in renewable energies in order to achieve the goals that we want to achieve. I made just a very simple exercise. I like maths, so this is very simple, but I think that this is quite representative. So we speak about, can we actually go to zero, completely zero energy building performance? Okay, we speak about, for instance, PV panels, the photovoltaics, which is nowadays how we cover this excess that we need to cover in order to be net zero. I mean, 1 kilowatt peak power now is around 8 square meters. We speak about the energy that can deliver 8 square meters in Madrid is around 2,400 kilowatt hours per year. We consider how much is this per square meter. It's around 300 kilowatt hours per square meter. And we think, okay, we have just one floor plan building. This could be covered. We could meet net zero. Let's say we cover the whole roof with solar panels. As a consequence of what I have explained before. If we have 2 floor plans, then we need to go down in the demand by 50% and go down to 150 kilowatt hour per square meter. And we can continue like that. And we see like a 10 floor plan building, we actually need to go quite low. We need to go to 30 kilowatt hours per square meter of energy demand in order to be net zero. And we know that nowadays this is feasible with the technologies that we have and with the knowledge that we have from the architects and the other disciplines. So now, a standard office building in Madrid, just to compare, consumes around 240 kilowatt hours per square meter. I mean, 8 times more. So I mean, we can say that we are quite behind the way that we should do the things. But we are in the right path with the new buildings. And this is a little bit the tendency. You see that it has been, as I mentioned, a revolution in the last years. I mean, if we see the consumptions that we had in the 70s in the standard building, around 700 kilowatt hours per square meter, and how much we are having standard offices now around 240. I mean, not a good one, but then 10 years old and 15 years old building, and how we should perform in order to meet this net zero. So it's a big change. And I wanted to make the same exercise with another industry that is, everybody knows, the car industry. We have more or less the same tendency. We see in the 70s a car that can consume around 10 liters per 100 kilometers. And in 2010, maybe we could be around 5. Now, with the new cars, electric cars, hybrids, actually, we could go down 8 times more. So we are more or less in the same level. So this is what I mentioned before. We are in a revolution time. And it's time for us, for the technicians and the engineers, professionals, to put all of this in, to put all our knowledge in place and to actually implement this in the new buildings, to help the society actually to make the change happen. Yes, I mean, you can see here in the pictures that all classical installations that we use in buildings, the ones below, maybe they are nowadays installations, but actually we can do it better. I mean, we can use processes that actually we are using now. We can work with 3D modeling. We can work with building engineering physics with all of the disciplines that, for instance, there on the bottom left, you can see with radiation simulations. We can work with wind simulations. We can integrate building information modeling in our design to see everything that can happen in advance. And when we speak about buildings, actually, we have new technologies that we can adapt. And one of the examples is what I was going to talk today, that is the TAPS. TAPS is the acronym for Thermal Activated Building Structure. So actually what we are doing, as we did in this building where I'm sitting now, is we have integrated a piping in the concrete, in the slabs with the water circuit in order to get the right comfort for cooling and heating. So this, in this case, in this building, this piping is connected to a cooling tower and to a boiler. But the best scenario will be that this is kind of connected, for instance, with a geothermal heat pump. Could be the best combination. And here, this is a funny picture that I like. So this is in the 19th century. We can think that the buildings, they were quite important for the whole comfort performance. I mean, we think about, for instance, patios in Andalusia, or maybe the English cottage, where we have thermal mass, we have bricks, we have small windows. I mean, you were thinking about how to get a good climate without so many active systems. Maybe you have a chimney or something like that. And then in the 20th century came all of these machines that we wanted to install. We, the engineers, we are so happy to install machines, and they produce a lot of noise, and that we see that also they produce a lot of discomfort. And then, you have air conditioning on your back, and it's not working either. So we go to the 21st century, and what we see is like we need to design with an holistic approach. I mean, we need to design with passive solutions. The architects, they need to integrate the sustainability concept from the very beginning. And the active systems are just something that should be as small as possible, and just to cover what cannot be covered by passive solutions. So this is where we are now, where we try to implement in every single project. And this is the picture of how we perform these goals. We have specialities that are working both for the passive solutions and the active solutions in every single matter, and also we have professionals for doing that. So even if, for instance, in the architect department, even if this is an architecture department, we have professionals in all disciplines that can accomplish the whole work. This is a little bit what I mentioned. So it's kind of classic, mainly for engineers, that we are a little bit maybe conservative, to do the things as always has been done, and don't try to do new things, to think a little bit outside the box. So I say to the students now, like, you should think out the box now, from the very beginning. Try to perform and to do the things as best as possible for both, for the client, for the planet, and for everyone. Here is the headquarters, the Madrid headquarters, and you can see it was done in 2010. One of the things that is very peculiar for this building is has been extremely cheap. We try to be as cost efficient as possible. So we have built this project with this building with just 1,000 euros per square meter, which is very low. For 900 people, it's an office where the south facade is protected by a double skin. So we're using these passive solutions. And on the other side, we have a large windows facing north with a very nice diffuse light and very nice views. So we've been thinking always about health, energy performance, low investment, low maintenance, and a symbol for our company. Yeah, it was a double roof also to protect the installation. And it was also green roofs on the top, PV panels, a lot of natural light. Yeah, this is a bit repeating, but passive solutions, active solutions. I mean, the taps are a little bit in between, because taps, we are using the thermal mass of the slabs. So it's a combination of passive solution and active solution. So this is why they are a little bit in between. When we say their system efficiency is connected to these taps. And the renewables, they should be just used to cover the peaks. But before that, we need to really design so the demand is really as low as possible. Yeah, there you can see on the top left corner, you can see the north facade with a lot of glazing and very nice diffuse light coming in. We have some vertical protections for the sunset. And in the south facade, we have this double skin, and now it's a little bit greener because we have climbing plants. Also, in this building, I mean, you see that it's quite dry around. So we have also a harvesting tank that is collecting rainfall water to irrigate the gardens around and to use it for the toilets. This was the time of construction. You can see the insulation there. Double skin. In the south facade, we have meeting rooms that are not used regularly, the same as the north facade, where we have a landscape office plan. You can see there the industrial touch with exposed ceiling, and also even the fit out of the internal rooms. I mean, they're quite simple. This is what I was explaining about the thermal mass and the taps. You can see in the blue line the external temperatures and how the temperatures decrease when you have thermal insulation, and how decrease even more when you have thermal mass. And it's also kind of move towards when you have thermal mass. So when you have high temperatures, you will feel these high temperatures a little bit after inside the room. You have this kind of cathedral effect, it's called. No? You are using the thermal mass in an efficient way. And this is the taps. This is how we build it. So we have all of this piping inside the building. It's kind of like a floor heating, but actually you are also using the whole thermal mass. You don't have insulation below. So you are using both sides. You have above you, you have the ceiling with these taps. It's also cooling down the floor above. So you have an insulation in any side. And you see also what I mentioned about the thermal mass, it made you the possibility actually to charge the system during the night. For instance, using a cooling tower when the temperatures are lower, you can use this cooling tower and charge the whole system, the whole thermal mass. And during the day, you just switch off the system, and the system is just getting all the extra heat that is people and computers and all the internal guys are creating inside the building. And for winter, is the other way around. So it was a little bit the same when you are working the night day, you are charging the system, and during the day, you are actually discharging the system. And this is how it looks in when we have done the design. It's quite a lot of piping, you see. And this is the temperatures that actually we are getting very good comfort, and we don't get all the capacity from these taps. We need to cover the peaks with flow, with ventilation, but we get most of it actually. And also thinking about that the thermal activated systems, we are working with temperatures that make the system much more efficient, because we are working with temperatures that are very close to the comfort indoor temperature. So for instance, for a heating system that in the 90s was working with 80 degrees radiators, now with the taps, we just work with 26. So it's you connect this to a geothermal heat pump, the performance is extremely high. We get savings around 70, 80%, something like that. This is the system that we have in the Madrid headquarters with the cooling tower. You see there that we are just providing 19 degrees, nothing to compare with a typical chiller that you need to go down to 5 degrees to 6 degrees. So the difference are huge. And this is a thermography test that you see there, the temperatures of the slab with the piping. Yes. I mean, and you see there the results are so much better than before. I mean, we are saving, as I mentioned, I can show you now in the next picture. Yes. This is the numbers that we have done after 12 years. I mean, we are now performing with 70 kilowatt hours per square meter a year. This is very simple maths. I mean, 12 years, savings around 170 kilowatt hours per square meter. We are saving 1.7 million pounds so far, just in operational use. So as you can understand, everybody's quite happy here, and also the comfort is much better than before. Yeah, and this is the tendencies that we're having regarding carbon dioxide in different kind of buildings. As I mentioned before, the tendency is quite drastic. I mean, we really need to push. This is the same that I mentioned with thermal mass and cooling towers. We did this exercise just to see with taps how can we reduce the carbon dioxide. It's true that here you have the whole picture, so the influence of the taps is not as high as if you play from the beginning, showing all the changes that we have done, but just the tap saves around 100 kilos of carbon dioxide per year. Here you can see also the connection with the water in the central picture there, how we collect the water from the roof and how we use this for irrigate the gardening, and also we have some ponds there, some more water features. And also on the right side, you can see also the importance of the daylight in the staircase area, where we have also some areas to work, to have some meeting rooms. This building was certified as LEED Gold. So certifications are always like a way to demonstrate to the rest of the world, no, that we have done a good performance. And now, I mean, I have 5 minutes, I think, so I will try to go a little bit faster. But here, this project I personally like a lot. This is a holistic approach for a cellar designing, wine cellar design. This is for making wine in the north of Spain. Very pretty project that we have won different architecture prizes. I mean, you know that the wineries in the old times in Spain, they were buried. I mean, they were under the ground, trying to keep temperatures as good as possible. I mean, for the wine, I think it's around 15 degrees, the set point. But this is kind of difficult to make it nowadays. With the global warming, everything is just warmer. So these guys from these producers, they cannot get the same performance as before, even if they put it under the ground, because the ground now is hotter than before also. So we did a project where actually we have semi-buried the whole winery, and we put on the roof, on the top, we have installed these taps, trying to cool down the whole winery, trying to keep the temperatures as good as possible, and using a geothermal heat pump with free cooling. We pump water from the ground from 150 meters, and we circulate for all the taps. So actually, we can keep the wine with the exact right temperature all year around. You can see here on the right how the winery was placed there, and now we have moved to another place using also the topography, so it's semi-buried now. The solution is the one on the right. Here you can see also a very simple schematic where we have some areas for visiting and also another ones for production. These are the visit areas are also with taps, so we get a very good comfort. And for the production, the taps are just placed on the roof, because I mean, for the rest, I mean, we still get good temperature from the ground, but from the roof, because above the roof is just there are just some centimeters of ground with green roofs, and just the slab is not enough. We will get a lot of heat from above. I can show you in temperatures here. Let's see, very nice views from the production area and from the visiting area. Here it is very simple schematic where you can see that we have green roofs, and below this green roof we have the taps. We have the thermal activated structure for the slab, so we don't get so much heat or so much cold from outside into the barrel areas and into the visiting areas. We have also connected this with the representative concentration pathways that are established by the global warming communities. You can see there the different paths, and we have done some simulations with the most conservative one, the 4.5. So it says that it will decrease the temperature in this place by 2 degrees. And this is what we have done with these energy simulations. with the taps, with the thermal activated structure, we can see that the set point in 15 degrees, we can keep it quite well. You can see the red color, the red line is how we performing. So we are quite close to the set point ±1. And then you can see the pictures on the right. You can see how it's performing if you don't have thermal activated structure. You can see that the temperatures are far away from the set point. You can see the one in gray there, that is during the summer day, you are getting 20 degrees from this slab into the building, into the winery. And during the winter time, we are getting around 10 degrees. So it's not good at all. And this is the section, how we have done it with the slab above in the production area. We have the precast concrete, and above we have the taps after 12 centimeters of insulation and after the soil layer. It's very simple solution and very effective. This is the connection with the geothermal heat pump that actually in most of the time is just working in free cooling mode. So actually the heat pump is not working, it's off, and just a small recirculation pump is circulating water from the ground into the taps. And just for the peaks, we use the heat pump, just for the peak loads. And here you can see that slab heat balance, how you can see that without taps is crazy how unbalanced is the system, and with the taps is very balanced and working very smoothly. The client, I can see that they are super happy with us, and the performance and the cost is extremely low. Yeah, and this is with the situation that when the temperatures increase a lot. I mean, so this is also a lot connected with resilience against climate change, because we see now with the taps, if temperatures increase 2-3 degrees, we can control the situation. Without these taps, we will have a problem in the winery industry. They really need to start installing chillers, and it will be costly and not so good for the wine. And this is some additional examples that we have done for including taps. So I think this is the last slide, and it's exactly the time. So thanks a lot to everyone. I don't know.
So I wanted to add a
Thank
thing,
you,
if that's
Sergio.
okay. Sorry, can I just add one thing, just in terms of the tabs? I think one thing that Sergio didn't dwell on is the level of comfort that it provides in terms of noise.
Yes, good point.
If you want to elaborate on that, Sergio, or because that was one of the first.
Yes, I can tell you. Let's go to one of the slides. Maybe you can see better. Let me see. Yeah, what happened is a very good point, because let's go to because when you have taps, actually you don't have any noise at all. I mean, you compare with a standard building where you have, let's say this is a good picture. Yeah, in a standard building that you can see on the right there, I mean, you will have fan coils with noise above your head all the time, you know. I mean, when you stop the fan coils, you will see what is going on. I mean, it's strange. I don't hear anything. When you have taps, you don't hear anything. You just have ventilation. That in this case we have used this textile duct that is even better, because you don't even feel any ventilation, and you just have that the whole mass is releasing as a radiant cooling, so you don't have any noise at all. There is not any machine at all inside the rooms where people are working. We just have the air handling units for the ventilation far away on the roof, and the circulation pump for moving all of this water in the slabs. So it's no noise at all. So it's a huge difference, of course. This is a good point.
Thank you so much, Sergio. Really fascinating, and a lot to take in. Viral, I know you prompted a particular aspect that maybe was missing. Was there anything else you wanted to add, or are you happy to sort of take on questions and?
Yeah, happy to questions
Good.
and discussion.
Excellent. Well, I mean, I think I would, there are a couple of things that I would love to kick off, and then I will definitely refer to our chat, because I'm sure there are plenty of questions coming in. But I wondered, just purely on a sort of design, the sort of consequence of what is so fabulously light as a system. It feels very light, even when you see all of the pipes, which are slightly overwhelming visually. An amazing amount of equipment in a way, but really light, and in terms of physical intervention into spaces. Now, what does that do for ceiling heights and spans and all of the other bits that go to make up building? Are you seeing it having quite distinct consequences on?
I mean, one of the consequences that you have with taps is like, it's not recommended to have false ceiling. I mean, when you are using taps, you normally use exposed ceilings. So actually you have more height than in standard of, I mean, you are using just, I mean, it's naked. I mean, you don't have any false ceiling. So I see that this is something positive, but it's true that if someone wants to have a touch that is not so industrial touch, that they want to have another design that they really like the false ceilings, then is not working properly. Then this is one point. Regarding amount of installations, I mean, yes, it's true that you see a lot of piping there inside, but it's just that. After you are saving a lot of units inside the offices and ducting, and so for the architects, they normally love this system. It's just an issue that you need to prepare from the very beginning the design with this system, including in the design. I don't know if you want to add something, Viran?
Yeah, I mean, I think just taking up that point, Samantha, I think what we also find is that you're eliminating, you know, a network of services that you would normally find below the ceiling slab. So already you've reduced by half, you're just providing ventilation ductwork, not heating or cooling as well. So, you know, it gives you the opportunity to limit that ceiling void, even if you've got a false ceiling more for an aesthetics. You know, we've got baffles, which are more just to help with the acoustics and then to provide some sort of visual continuity across there. But you don't have all the complexities of the services and then, you know, having the crossovers and things like that that you need to do. And I think it is, you know, to a more raw approach to a building style, but I think that is an architecture that is more realistic. And I think if you look at a lot of buildings and the way that they're going, you know, they're embracing how the building performs and the elements that it contains. And I think, you know, showing the structure and understanding how the structure is helping you to cool the building is one of those.
Yeah. No, I think it's a very pleasant consequence. It's really nice. I'm glad you pointed out that it's a textile duct in that and image that we're looking at now. Because they also have a nice, they look light when they're in the space, which is also a really interesting choice too. I wondered, the other thing I was really wondering, and whether it's something I dare say in your conversations, when thinking about the sort of impact, the wider impact. So clearly you've looked at the impact of your particular headquarters building and in relation to the projects that you're doing. But that fantastic equation of you know, how much energy is being saved, how much resources being afforded, how much money you're saving. What if we were all doing this? What if every single building? Can you apply it to every new building, given that we're not supposed to be doing new build, or can it be integrated in a retrofit project?
You mean just about the taps, or you mean in general about?
I think I'm referring to tabs. I mean, is it possible to think about integrating it into a retrofit world, as it were?
Actually, we are doing that. So in a project that you see here, that is, let me show you the last reference in Santander. We are actually retrofitting a very old building with these taps, but it has been a major retrofitting. This building that you see there. This is a thermoactivated building. We are keeping the facades, of course. We need to remove, I mean, of course, I mean, you cannot keep the slabs. You need to take, make it new. So it's a large renovation. Yes, it's a large renovation when you want to install taps, and it's working when you have kind of a continuous use. So if you just use a building in a sporadic way, I mean, the thermal activation use the thermal mass, so it takes time to put everything in place, you know. So if it's a kind of building that just is on off all the time, that is not has not a continuous use, then taps is not maybe the best way.
Right.
Mm.
Got you.
I
So
think, sorry, Samantha, I'd also say that one thing that we found originally, and I think if you go back, I think we use it in an office building, and it was a tendency that, yeah, it kind of works well in office buildings where you have that regular use and the requirements for heating and cooling. But actually more recently, you know, we've been applying tabs now to projects in different sectors. So I think, you know, there are a few airport projects that we've been involved in, and other companies been involved in, where they've been introducing it to terminal design, for example. I think we're also introducing it at the moment in a manufacturing building as well. So I think it was obviously, you know, and we're going over 10, 13 years ago when we obviously did our project, it was one of the new technologies around, but as it's been developed, it's become much more flexible in the way that it can be used and operated. And that's why we're seeing that now it's the best solution in many projects for across different sectors.
I have to say also something else here. I mean, taps has to be related also with the integration of very good passive solutions, because if you don't have a very, very good thermal performance, for instance, good glazing, then it becomes a little bit tricky, because you still need to add an additional system in an important way. I mean, it's not, you will not cover most of the cooling, for instance, demand, or the heating demand, and then you need to add something else anyway. So it's very important that it's holistic, the whole approach, and you actually integrate passive solutions, other solutions, in order to actually decrease a lot this demand, and then in this way taps cover most of the demand.
got you. Yeah. Fantastic. I have one more question before I'm going to open this out to the chat. I'm sure give everyone time, a little bit more time to please put your questions in the chat. I can't guarantee I will see your hands raised otherwise. So do start filling the chat with your questions. You very early on mentioned that your team really it's really multidisciplinary. I mean, there are members of the team that are coming from all over in terms of their expertise. And I just wondered what that was like in a design meeting in terms of shared languages. And I mean the language of design and architecture and engineering. And, you know, what does it mean when you're a biologist sitting at that table? How has it been to build that team in order to do these kinds of projects and come up with these kinds of design solutions?
Yeah, this is a very good question. Yes, I see that this, for instance, I put this in the connected with the sustainability team that we have now. In the sustainability team, we have a mixture of architects, engineers from different disciplines, and you can see that when you work with the sustainability, and you have all of these paths that you need to go. You need to think about water, you need to think about materials, you need to think about so many issues. That's actually, you realize how important it is to have all of these disciplines, because you cannot be good at everything. I mean, you need to have people that has been studying particular issues. So if it's needed to have this combination, I think, if we want to perform the best way, I mean, we need to have this mixture of people from different disciplines, and this has to be connected with the architects. And before, architects used to have this kind of I don't know, that they normally used to decide maybe everything, no? And now it's much more open, no? We are everybody working together in a team, and this makes the solutions much more efficient in general.
I guess my sort of associated question then with that idea, I mean, you alluded to it, architects' role shifting a little, maybe, you know, having to take on other ways of thinking and maybe not so much compromise, but really integrate other layers of expertise into design thinking. And whether you think architectural education, I mean, I'm thinking globally now, not just from a UK position, but whether architectural education is kind of adapting to that sufficiently. Are you finding that? Are you finding students coming through that have that breadth of accepting that there are other disciplines that need to inform?
Absolutely. I think that the new generations are much more concerned about other issues, about sustainability issues and other issues. And I see that there are more and more architects that are concerned about the whole approach. I mean, integrating building physics. I see it in daily basis in our office that yeah, we are moving in the right direction. So yes, I think that I guess that you're doing well at the universities because people are coming more concerned about these issues.
I mean, I think I definitely see the concern. I suppose as an educator myself and coming, you know, being in the context of this conversation, I think it's a big it's equally, I think, a big shift for education to make sure that the way that projects are being developed and are also adapting the emphasis, the expectations of what those projects are trying to achieve really do focus some of these issues, much more privilege these issues, but allow the imagination to keep pushing at the edges.
I think, Samantha, one thing that I found, and obviously working in an engineering company, and especially over the last, maybe more so over the last 10, 15 years, where I've started to integrate more with the building physics team as it's been developed, is maybe actually understanding some of the simple principles of, you know, numbers and things like that. I mean, I think, Sergio, you put a very nice couple of slides up explaining, you know, what it means to generate energy, you know, but, you know, the simple things, difference between, you know, what is a kilowatt, a kilowatt hour, the power demand and things like that. These are the nuances of the reality of design that, you know, we as architects need to understand. You know, when we look at numbers and we see numbers, you know, we're kind of just taking it for given that someone's saying that this is more efficient than something else, but without actually understanding what it means. And I think, you know, that for me is the eye opener. When you start to realize, and you know, maybe it's the maths geek in me, but when you start to understand the maths and the numbers, then you really understand what your design decisions mean for you.
Yeah. I think that it's a clear risk that there are many people in the branch that talk a lot about these issues without actually putting on place the issues. You know, I mean, like making them real. This is a clear risk. I mean, and we try to avoid this as much as possible. I mean, we really try to prove every single step that we take with numbers, because it's what we need to do. I mean, at the end, it's a performance, and the client needs to not just hear nice words; they really need to see the reality.
Yeah. No, I mean, I think it's a great point. It is those principles. If you don't understand the base rules, then yes, you really don't know the material you're working with. So I just think that's an incredibly useful thing to be reminded of. Now I'm going to go and see if we have some questions, and I think we have one here so far, and so I'm going to start with that. Excellent talk, Sergio and Viral, from Maria. Do you have sustainability protocols in the day-to-day running of your office?
Yes, I mean, sustainability protocols. I mean, we have a sustainability policy in the company, a general corporate sustainability policy. And but if you speak about the design, we also have a methodology, a sustainability methodology. So and we are improving this methodology in every single project. We use the projects to improve our methodology, but we know from the very beginning how to approach. The first thing is like we really need to understand the client to see what the goals are and to try to sometimes a little bit like to try to educate in a way, because some clients they come with some ideas but they don't have clear ideas, so we need really to clarify them what they want sometimes or what is possible to achieve.
I think we're also, I mean, we're ISO 14001, which is the environmental management system certified.
Yeah.
Within that, we have to, we have to report internally how we're performing against targets. So we set our own internal targets and we look at that. And I think, Sergio, you mentioned, again, in the presentation earlier that, we have monitoring devices in the building that allow us to continuously understand what our energy demands are and performances are, so we can look at where spikes might be or where they're happening. Because, over a 12-year lifespan, you should understand your building. And then suddenly, if you find that there is something not functioning right, the first place you're probably going to hear it or see it is that actually in your energy demands, suddenly if one of the pipes is not working or there's a pump not working, it will sense it, but also your performance of the building with there. So I think we've got a number of measures that we do, and I think it's always important. We here in the UK we're a little bit different. Obviously, Spain has a big office of 900 people that we're looking at there. In the London, we're an office of 15 in an old building. Where can we make the difference? I think we make the difference in what we do every day, and I think again we set ourselves certain targets internally about, again, you can't stop people from printing, but you ask the right questions of the team, what can you do as an individual? And then as an ethos, that goes through all the way to the top and then into your design work.
Yes.
Great. Inspiring. One, I think we should adopt. We don't have a sustainability policy in our school, and it's probably something we really should do. We try to guide by some principles, I suppose, but not on the day-to-day running. So I think that's quite a helpful one. I'm looking to see if there are any more questions, and there don't seem to be, which I cannot believe. So we're not far off wrapping up. So I'm going to put out a last call to our audience, which I think are largely students actually, and first-year students, I think, which is good to see, but perhaps not quite ready to ask questions, not limbered up enough.
Don't feel afraid to ask
No,
questions.
exactly.
Can be as silly as you want. They don't mind.
I mean, so I will give everyone a few more minutes, last chances, before we do wrap up. I'm totally intrigued to see it's sort of tantalizing, the size of the images you've put in, Sergio, of the interiors of the office, and I'm sort of looking at the river that's running through in the planting. So it would be really nice to get a feel for that space inside. But I'm sort of struck by the location of the office, the view. Not in an urban setting, and I wondered whether it's more challenging in terms of because you've got all of the other. Maybe it isn't more challenging. An exposed area in the south of Spain is probably as challenging as being in the centre of London. But are the parameters really extremely different in those different conditions when you're trying to work with
just on that, I think, what we're finding and what we're doing is, and I think this is not, tabs is not for, hot climates. It's not just for Spain. We've introduced it in a project in Ireland already, and I've seen it in Scandinavian countries, I think, Sergio. I think, so the misconception is that. Now, what's important, as Sergio mentioned, is the passive design features are critical. Get your orientation right. But again, so in an urban environment, you're lucky. You probably, in the city centers, you have a lot of shading already by surrounding buildings, so you're going to reduce your heat gains and things, whether you're in London or you're in somewhere else. Obviously, at certain times you want the heat gain, but I think solution.
Yeah. Yes, I mean the design, the invention of the taps was done by a professor at the DTU University from Copenhagen in Denmark. So yeah, it's a very different climate.
Yeah.
And
Yeah, well, that's good to know. Right. Well, I'm going to wrap up. It doesn't appear too nervous to ask questions out there for some. Maybe everybody's just wondering where they can get their hands on tabs and trying to figure out how to deploy it into their next scheme. But I have to say thank you so much to both of you. John has a question. John is just typing his question. One more. John, LSA, how do conversations go with clients when presenting this to them as part of the build project? What barriers do you face with them, and what are the common misconceptions that need addressing?
Can I answer that one, Sergio? Because we had this quite recently. A couple of years ago, we were working with an airport client, and they were very apprehensive about it. First of all, because they were concerned of the technology. For them, it was a new technology. So part of the work that we first did was to kind of give them a full explanation of what it is, how it works, how it benefits buildings. Also, you have to address their concerns, which are, how it actually affects their actual project and their building. So for an airport terminal building where things are constantly changing and moving around, I'm sure, we get to terminals and you see shops suddenly appear and things like that, or, they've moved equipment around and they need to fix things in new places. Obviously, if you've not got a system that allows you to be flexible, then you have issues. And obviously, again, you need to explain to them the limitations of the system and how do you address them is important in the design phase. And we managed to convince them. So there is a lot of work going into convincing them. But then what you also have to show them is how this project literally benefits them in terms of, their overall strategy of getting to net zero, meeting their obligations as a client from sustainability perspective. And, you do the analysis, you go through optioneering, you show the alternative systems, what the paybacks are, if they're better or worse. You do, several energy models with the different systems, and then you can literally turn around and say, look, this is the best performing system and this is what you should do. I mean, it isn't, easy, because it's something that a lot of clients are still to become aware of. But it takes time and a bit more effort than you normally would, but it's worth it.
One thing that we have advantage for is we have already references, and we have our building as a main reference. So they are fascinated when they come here and they see the reality. So this is the best way to prove, is to show a reference.
I was going to say, does every client meeting start with a visit to your office? I suspect that helps.
Yeah,
does help, yes. We brought a client to our office recently, and they were like, oh, but can we use this? Can we use that? Can we have this? And, we kind of were saying, yes, you can have this, you can't have this, because obviously their design was a very different at that moment. But, they understand it. And as I said earlier in my, one of the things is that it creates a different environment. The approach that you take to sustainability, and using the passive systems and tabs, it's in the middle. It's something that, until I think for me, having visited our old offices in Madrid and things, and then gone to the new one after it was completed, the step change in people's attitudes was impressive. There was a feeling of calmness and tranquility, and as you say, you look at the images where you've got these gardens on the ground floor with the ponds and things, where you see when it's raining, you see the water coming down and trickling in there. You actually see the water, you know, you actually see water filling into those ponds, and you understand the way the building works.
It's pedagogic also.
Yeah, fantastic. Well, it's really inspiring to see the work. Thank you so much for sharing it, both of you.